So I've got some questions here for you to answer. This first one is, if you were to put things on a tablecloth and pull the tablecloth out quickly, what would happen to the things? Or can you get the things to just to kind of stay there? And that's Newton's first law. Kind of talk about that, and I kind of on my lecture slides did an example of coins on a piece of paper. Makes me want to go try that. Newton's second law, this is, oh no, this isn't Newton's second law. This is just simply about forces. So I have a pair of questions here. You're only supposed to answer problem number 2. You don't have to answer problem number 1, but it's similar. So, and it goes like this. Remember, sometimes it's helpful to make a drawing of what's going on. So here I have my box here. I have a force applied in kind of the same line of sight in 2 directions. One is from left to right, 250 newtons, and the other force is from right back to left, 600 newtons. And you'd be like, if this is a push of war instead of a tug of war or push of war, of course that right to left would win out. And we can actually calculate the net force, net resultant force of those 2 forces added together by simple subtraction in this case. So the question is, what force would I need to apply to make the box stay where it is? So I think you'll be okay with that. And then on to Newton's second law. So this is basically, again, a pair of questions. You only have to answer question number 6. So we're going to apply a net force of 6 newtons, and the mass of the object is given. So we have the force and the mass, and you're supposed to come up with acceleration. Now this is a good example of maybe if you think F for force, M for mass, A for acceleration, you might be able to kind of come up, and on your unit exams I will have this equation for you with this equation. So we know the force and we know the mass, and we're trying to find the acceleration. So sometimes I just kind of, if I don't have a picture necessarily to draw, I pull the what we know out of the problem and what we're trying to find out of the problem. So what I would do actually is rewrite F is equal to ma, and I would try to get acceleration by itself because that's what I'm trying to solve for. So as you may know, and if you don't have to do it this way, but to get acceleration by itself, if I divide both sides of the equal sign, on either side of the equal sign, by m, then my m's will cancel and I'll be left with acceleration by itself. So if I just simply take that force and divide it by mass, I should get acceleration. There's a little bit of just one more thing to this. I want you to try to at least have a sense for what the units of these are. And so units of force are newtons. Now, newtons actually can be expanded to kilograms or broken down to kilograms, meters per second squared. That's what a newton is. That's what my 6.0 newtons is, kilograms, meters per second squared. Mass was in kilograms, and acceleration, we said, should always be in in distance per time squared. So in this case, meters per second squared.